Hey guys, today we're going to do 4.2, graphing rational functions. The first thing we have to do is rewrite a rational function to identify asymptotes, so to have it in the form we saw yesterday. Actually, it wasn't yesterday, it was Friday. So first we'll do long division. Before we do that, I want to show you just as a reminder how you do long division, so it'll help us because it's probably been a while since we've done that. So 9 divided by 2, for example, how many times does 2 go into 9? 4 times. 2 times 4 is 8. And then we subtract to find a remainder, which is 1. So what we'll end up with is 4 wholes plus 1 out of 2. And again, we would just say 4.5, but hopefully that will help us a little as we get into this. So now if we write 4x divided by x minus 3, we want to see how many times x goes into 4x first, which is 4 times. So 4 times x minus 3, we just distribute 4 to the x and the negative 3, so we end up with 4x minus 12. Put that in parentheses and subtract it, because that's how we'll find our remainder, is by subtracting. So 4x minus 4x goes away, it's 0. We have an invisible 0 here. 0 minus a negative 12 is 12. So that is our remainder. So what we end up with is 4 wholes plus a remainder of 12 over x minus 3. Using the function form we did in 4.1, we can rewrite this as g of x equals 12 over x minus 3 plus 4. Technically either form would work. So now we'll talk about the domain, the range, and the asymptotes. So the domain, first of all, is anything x can't be. And since a denominator can't be 0, x minus 3 can't be 0, so x can't be 3. The range, basically this whole term cannot be 0, so we can't get 0 plus 4 or 4 for y. So then for our asymptotes, instead of saying what they can't be, we're saying what it is, because we can graph our line at x equals 3. That can't be crossed. And y equals 4. Sorry about that. That should be a 4. That can't be crossed either. So those are our asymptotes. So then x equals 3 will be right there. Y equals 4. It's right there. So now technically, we know that we're going to have curves in 2 quadrants going towards the asymptotes, but we should check a point so we make sure we have it's either going to be here and here, 1 and 3, or 2 and 4. So if we check 0, just because that's an easy one when we can use it, we'll get 4 times 0, which is 0, over 0 minus 3, which is negative 3, which is just 0. So then our point that we have is 0, 0. So if we plot it right there, we know that's going to be part of it, and the other part of it will be on the other side. So we have quadrants 1 and 3. Let's try another one. We do 6x divided by 2x plus 1. 2x goes into 6x 3 times, and then 3 times 2x plus 1. We can distribute and get 3 times 2x, which is 6x, 3 times 1, which is 3. And then we're going to subtract, because that's how long division works. 6x minus 6x, those go away. Invisible 0. 0 minus 3, negative 3. There's our remainder. So we have 3 wholes plus negative 3 over 2x plus 1. And kind of the way we like to see it is more f of x equals negative 3 over 2x plus 1 plus 3. And now asymptotes from here. So first of all, that denominator can't be 0. I guess domain first of all. So 2x plus 1 can't be 0. 2x can't be negative 1. X can't be negative 1/2. Okay, so that's our domain. For our range, we know this whole term can't be 0. So f of x can't be 3, or y can't be 3. Our asymptotes are just flipping those around, because remember, the domain and range are what values x and y can't be, and the asymptotes are what they can't cross. So we have x equals -1/2 for our vertical asymptote, and y equals 3 for our horizontal. So x equals -1/2, go right there, y equals 3, go right there. You can pick a test point. Let's do 0 again because it's within the domain and because it's an easy one to use. So 6 times 0 over 2 times 0 plus 1. 0 over 1, which is 0, so we get to use 0, 0 again. So we know this time, since we have that point, we have quadrants 2 and 4. Okay, I would recommend that you stop this video and try this one on your own, and then come back and I will go over it. Okay, so x divided by x minus 6. X goes into x once, and 1 times x minus 6. This should be an easy enough one to do in your head, but I'll write it over here just in case. So we just get x minus 6. Subtract, the x's go away. Invisible 0 minus -6, 6. So I end up with 1 whole plus a remainder of 6 over x minus 6. So we'll write it as f of x equals 6 over x minus 6 plus 1. So now, domain, x can't be 6 because that can't be 0. Our range, since this can't be 0, y can't be 1. So then our asymptotes, x equals 6, because x can't cross that. Y equals 1, y can't cross that. So x equals 6, y equals 1. We'll do our test point. 0 works again. F of 0 is going to be 0 over 0 minus 6, which is 0. You can use 0, 0 for a third time here. There's 0, 0. Continue past the asymptotes. So we have quadrants 1 and 3 again. I'm not going to talk too much about this concept box, rational functions. Basically, you end up with a fraction with a rational function on top and bottom, or with a polynomial, rather, on the top and the bottom. So for asymptotes of rational functions, the vertical asymptotes are about the same as what we've been doing. They occur at the x values where the function is undefined, which is when the denominator of the rational function is equal to 0. Horizontal asymptotes are a little bit different. So normally we would do long division, or not normally, but so far we've done long division, but that only works if it's a simple enough expression or equation. As it is, in this case, we're going to look at the degree of the numerator, the degree of the denominator. So the first case we have where the degree of the numerator, in this case 1, is less than the degree of the denominator. So whenever that occurs, as x increases, the denominator gets very large. So you end up with a smaller number over a larger number. And whenever that happens, when the denominator gets really big, for example, let's say we have 1 over, I don't know, a million. It's going to be 0.00 something, right? So that's getting close to 0. So as the denominator gets larger, and once it gets large enough, we don't care about these, they don't matter. F of x will go to 0. So your horizontal asymptote is y equals 0. Our second case is when the degree of the numerator, in this case 2, is larger than the degree of the denominator, in this case 1. So as x increases this time, the numerator gets very large. So you end up with a large number over a smaller number. And essentially, whenever the top gets larger, it's going to go towards infinity. It'll just get bigger and bigger. It won't stop anywhere. So f of x goes to infinity. So there is no horizontal asymptote because it won't get stopped by any line. Case 3 is where the numerator and denominator have the same degree in this case too. And what happens? Again, when you zoom out far enough, it's similar to how when you think of the graph of x squared, or x to the 8th, x to the 4th, x to the 6th, when you zoom out far enough, they will all be this U-shaped parabola. Similar here with this f of x, if you zoom out far enough, we don't worry about these anymore. All we worry about is our leading terms. And when the degree is the same, the numerator and denominator go up at the same rate. So our asymptote will be the ratio of the coefficients. Sorry, that one's hard to read. Coefficients of the leading terms. So in this case, 2 over 1. So our asymptote would be y equals 2. Okay, let's go to the next page and do some examples. So first of all, vertical asymptotes. So we want the denominator. We set the denominator equal to 0 to find out what those are. So x squared plus 7x plus, this should be a 12, and I think in yours is a 12, equals 0. Now it's back to x box. I know you missed it. So ac x squared, 12x squared, 7x goes here, so we need the numbers that add to 7 and multiply to 12. So that's 4x and 3x. Go for our box. X squared goes here, 12 goes here, and we take our 4x and 3x and put them in the middle two boxes. So now we can pull an x out of there, 4, an x, and a 3. So we rewrite as x plus 3 times x minus 4 equals 0. We set x plus 3 equals 0, we get x equals negative 3. We set x plus 4 equal to 0, we get x equals negative 4. So those are our two vertical asymptotes. For the horizontal, these examples, there will only be one. We look only at the leading terms, so 3x and x squared. Since the degree of the numerator is smaller, basically the denominator will get really, really big as x gets bigger. So f of x will go to 0, so a horizontal asymptote is y equals 0. For our second example, we'll set x squared minus 2x minus 8 equal to 0. Do our x box, so ac x squared, negative 8x squared, negative 2x. We need numbers that add to negative 2 and multiply to be negative 8. So we have negative 4x and 2x. Use our box. We have x squared, negative 8, negative 4x, 2x. We can pull out an x and an x, a 2 and a negative 4. We can multiply to make sure those work. X times x squared, x times negative 4, times x, 2 times negative 4, and they do. So we can rewrite as x minus 4 times x plus 2 equals 0. So x equals 4 and x equals negative 2 are our vertical asymptotes. For the horizontal, same degree on top and bottom. So we can just do 2 over 1. So our asymptote for horizontal will be y equals 2. We will finish the rest of these notes next time I see you in class. And that's about it. Have a great day.